most of the PhD scholars using these statistical tools for their thesis, right? So in the thesis, normally all the tools they're using, but they are using regression analysis. This is one of the important the statistical tool in the statistical parts, right? So today I'm going to explain about the what is the regression analysis, and how to where to use, how to use, and how to interpret the regression analysis, right? So in this session, not only my speech, right, you are also going to give the answers, because in between the slides I asked so many questions, right? So you have to give the answers about the hypothesis and so many things I asked in the slides. Okay, so the participants, please ready to answer the questions during the session, right? So now I'm going to explain about the regression analysis. The first regression, the word first introduced used by Sir Francis Gordon in 1877, right? So he was used this the regression analysis, right, for identifying the relationship between the heights of father and sons when in the year of 1877, right? So this regression analysis going to use it to predict the two variables relationship. Okay, what is the closeness and what is the impact and what is the influence relationship between two or more variables, right? In this regression analysis, now two variables means one is independent variable, another one is dependent variables. So compulsorily we should use independent variables and dependent variables. Two variables very very important. So in this regression analysis, right, we can using these statistical tools to evaluate, to study the effect of one variable on another variable. Effect of one variable means what? Independent variable, right, on another variable. That is another variable means dependent variables. So this regression analysis is going to evaluate the relationship or impact of independent variables on dependent variables. So that purpose only we are using this regression analysis, right? And in the statistical process, it is to estimate or to calculate the relationship among the variables, right? Among the variables, again I tell you, the two or more variables, that is the independent variables and the dependent variables, right? So here, dependent variables are called the criterion variables. Then independent variables are called predictor variable or constant variable. Okay, independent variables are called predictor variable or constant variable, but the dependent variables are criterion variables, right? So there are two type of regression analysis we are mostly using in the thesis, right? One is simple or linear regression analysis. Simple regression analysis means one independent variable, one dependent variable. So that time we can use it for regression analysis when one dependent variable but many number of independent variables. So that time we can use the multiple regression analysis. Again I tell you, simple regression means only one independent variable, one dependent variable, right? So that is a simple regression analysis. Then the multiple regression analysis means more than two. There's a number of independent variables but only one dependent variable. So that is a multiple regression analysis, right? So now I'm going to explain when to use the regression test, regression analysis, right? So the simple regression analysis, right? Say one independent variables, one dependent variable. That time we can use it regression test. And why should we use for this regression test to predict the relationship between the variables, right? Independent variables and dependent variables, right? And another thing is what is the use? What purpose we are using means which variable the predict the more. Okay, more means what? Predicting means influencing, right? Or positive predictor variable or negative predictor variables. Which variable having a positive predictor and a negative predictor on the dependent variables, right? So we can easily identify the positive and the negative predictor variables, right? So and we can enter many number of independent variables, and it tells you which are the best predictors. Best predictors means what? Most influencing the factor, okay, independent variables, right, on the dependent variables, right. For example, here I given IV means independent variables, DV means dependent variable. So here independent variables: drug use, alcohol use, child abuse, these are all independent variables. Small example. Okay, so this how it is depend influencing or predicting the suicidal tendencies, right. Another one example, I'll tell you, that one I explained the end of this session, right, with the example. For example, impact of human resource development practices on organizational development. Okay, organization development is a dependent variable, but human resource development practices is independent variables. For example, manpower planning, recruitment, selection, training, right, then placement, then these are all coming under independent variable, that is a human resource development practices. I will explain last, right. Next, multiple regression. Okay, what do you mean multiple regression? Right, the multiple regression, it is also the independent variables going to predict the value of dependent variables. So that is a very simple. Okay, regression means what? One variable, independent variables predicting dependent variables. Then what is the the value? Okay, so here once the relationship between the variables determines whether the independent variables explain a significant variations in the dependent variables or not, right. So the multiple regression means what? So many number of independent variables predicting the independent variables. So that is called a multiple regression, right. So I have given one example, dependent variable and independent variables. So here the sleeping. Okay, so we can take the number of students data. Okay, so independent data and dependent data. Dependent data means their test score, the result. Okay, how much marks they are scoring in the test. But independent variables, here how many hours the student sleeping before the exam. Okay, so tomorrow exam. Okay, just assume that tomorrow exam, right, you are collecting the data from the students. Okay, how many students, how many hours they are sleeping. Okay, one student 8 hours, another student 7 hours, another student 5 hours, right, another student 10 hours, like that they are sleeping. Okay, so then end of the next day after the test, you check the mark. Then you enter the they enter the marks, the respective of the students. Okay, then we can easily calculate. We can easily evaluate the relationship between independent variables and the dependent variables. Okay, so for example, any relationship between this one sleeping, how many hours sleeping before the test, and what is the test performance, right. So here the sleeping means that is the independent variables. Then the score test mark is the dependent variables. So that's why I given here independent variables, right. So the independent variable is changing. Okay, the person to person will be changed, right. So it will not be predicted by any other variables, but these independent variables only going to affect or influence the another variables, right. But the independent variables not affected by any other variables, right. Then what is the dependent variables here, right. So here the response to a change in the independent variable, right, depending on the independent variables. Okay, so the test marks and the test performance of the students is based upon the the students previous day activities, particularly sleep, right. So so here dependent variables are called the responding variable or endogenous variable, right. But here independent variables are exogenous variable or predictor variable or the constant variable, right. So next, here I have given examples, right. So independent variables and dependent variables, right. So the researcher is looking for the possible effect on dependent variable that might caused by changing the independent variables. Okay, so from this the slides we can easily understand that, right, the dependent variables are caused or influenced or impacted by independent variables. So here how the independent variables, the causes on effect on dependent variables, right? So the previous slide I shown, no, this one. So based upon this, experiment, test scores impacted by amount of time spent sleeping the night before a test. Okay, so the students, how many hours they are sleeping before the test. Okay, then after that, what is the test score? Okay, so here, what is the hypothesis? Right, how long you sleep? There is an independent variable, right, affects your test score, the students test score, that is a dependent variables. Okay, so one students sleeping 8 hours, right, he scored 70 marks example, right, another student only the 5 hours, he scored 80 marks, 90 marks, like that. Okay, so you collect the students data about how many hours they sleep in the previous day of exam, and then what is the test score, then you can conduct the regression analysis, right? Then we come to know that, then what is the, the sleeping, okay, number of hours sleep, right, causes an effect of, the, dependent variable, that is a test score. Okay, test score means the result, right? Now the questions for you, who is used the regression first in 1877? Please use chat box. Who is used the regression first in 1877? The questions for participants. Who is used the regression first in 1877? Okay. The participant, you can use chat box. Give the answers for this question. Who is used the regression first in 1877? Okay. So the answer is Sir Francis Galton. Okay, so he is used the regression, the word in the of 1877 to study the, the height of, the father and the son. Okay, next. Now use the chat box. Participant, please use chat box. This is hypothesis, right? Now you tell me which one is an independent variable and which one is dependent variables, right? So lack of sleep significantly affects learning in 10-year old boys. Okay, so just to mention IV and DV. Which what is the IV and what is the DV? IV means independent variable, DV means dependent variable. What is IV in this hypothesis? Independent variable. Okay. So in this, based upon this hypothesis, right, independent variables are the sleep. Okay. Then dependent variable is a learning, right? Next hypothesis, the social class has a significant effect on IQ scores. Please use chat box. Please use chat box. Which one is independent variable? Which one is dependent variable? Dear participant, please use chat box. Social class has a significant effect on IQ scores. Yes. Okay. So here, social class is an independent variable and IQ scores, right? So that is a dependent variable. Next, this one hypothesis: stressful experiences significantly increase the livelihood of headaches. So what is the IV independent variables? What is the independent variable? Experience or a headache? Which one is independent variable? Which one is an dependent variable based upon this hypothesis? Right. So here experience is a independent variable, headache is a dependent variable. Next one is next hypothesis, time of study, time of day has a significant effect on alertness. Time of day, that is a independent variable, alertness is a dependent variables. So here independent variables effects on alertness the dependent variables, right? So now come to the regression analysis, linear regression analysis. In the linear regression analysis, there's a formula is y equal to alpha plus beta x, right? Linear regression formula y equal to alpha plus beta x. There is a linear regression formula, right? Y nothing but y, y means dependent variable, x means independent variables, right? Y means dependent variable, x means independent variables, right? So here alpha and the beta, these are two constants called regression coefficients, right? So then beta, this this is slope coefficient, right? That is a change in the value of y, right? Corresponding change in 1 unit of x. Then alpha equal to, alpha means y intercept when x equal to 0, right? So when you see this formula is confused, but when you come to this the statistical part is very easy. And r square, okay, r square means there's a there's a strength of association, right? What degrees that variation in y can be explained by x, right? So suppose r means this r square is 0.10 means 10 percentages, just you have to you have to multiply into 100, right? So the r square means there's a value is 0.1 means the 10 percentages influencing on dependent variables, right? So here the test of significance of regression equation. Regression equation, okay, linear regression, y equal to alpha plus beta x, right? So here I know the null hypothesis. Null hypothesis h naught beta equal to 0, right? Equal to 0. The hypothesis there is no linear relationship between y and x. Then h naught, then alternate hypothesis h1 beta unequal to 0. There is the linear relationship between y and x. So here I used the hypothesis, right? The null hypothesis h naught, school climate is having impact on academic achievements. Alternate hypothesis h1, school climate is not having impact on academic achievements, right? Please use chat box. Okay, what do you mean no school climate? Okay, the school climate, and what is mean the academic achievements? Please use chat box. What do you mean school climate? What are the variables? School climate, right? Okay, school climate means, okay, the atmosphere, school atmosphere, student teacher relationship, and the students and students relationship, and the facilities in the school, right? Maybe infrastructure facilities, classroom atmosphere, the food, everything is a school climate. Then academic achievement means the test score. Okay, students test performance, right? So how much percentage they are scoring in the each and every subject. Okay, So here, you should be accept the null hypothesis. Accept the H naught. H naught means null hypothesis if the p value is greater than 0.05. Okay, what do you mean 0.05? 0.05 means the level of significance, the 5 percentages. Okay, what do you mean the level of significance 5 percentages? Normally in the the statistics, when you are going to calculate the sample size, that time confidence level, confidence interval, two things will be considered. Okay, confidence level 95 percentage means what is the confidence interval? 5 percentages. Confidence level, suppose your confidence level 95 percentage means, right, confidence interval 5 percentages. Then suppose you are doing the research in the science, right, that time confidence level is 99 percentage, then confidence interval is only 1 percentages. So but social sciences, commerce, management, economics, and other psychology and all, right, so you should be take the confidence level 95 percentages, then confidence interval 5 percentages. So that 5 percentage only, there's a level of significance. Okay, the 5%, 5 divided by 5 percentage means 5 divided by 100, 0.05. So when you are calculating the when you are using statistical tool, statistical software, SPSS or any other software, that time you will get the p value. Okay, the probability value. Okay, so the probability value is greater than 0.05 means the null hypothesis is accepted. In case your p value is less than 0.05 means we should be reject the null hypothesis, accept the this one, accept the already hypothesis. Then this one, say example for regression analysis. Example for regression analysis, right? School climate and academic achievements. School climate and academic achievements. Okay, so here the 25, 34, 55, 45, let's say 56, 49, 65. That is here total number of sample size. Total number of the variables are, okay. There are this one 25 means there is a overall value of the particular the variables, right? Then academic achievements, the 58, 62, 80, 75, 84, 72, 89. So when you are applying this regression analysis for this variables, the school climate is independent variables, academic achievements are dependent variables, right? So see the figure, the first one, variables entered or removed. Okay, so that is no problem. But next one you see the model summary. Okay, so the model summary is very important. So here what is the predictor? Predictor means constant variable, the school climate. The predictors means this independent variables, right? So dependent variables, academic achievements. So what is the R value, right? 0.978. Okay, then R square is 0.957. Okay, so 957 means 95.7 percentage is influencing, right? So school climate influencing the academic achievements, right? So now come to the the ANOVA here, no significance value. Okay, significance value, there's a SIG 0.000, there is a p value. So the p value is 0. Okay, so what it mean, that is the p value is less than 0.05. Okay, so that's why, so we should be reject the null hypothesis, accept the accept the alternative hypothesis. Then so here the last one, the coefficient, the school climate, okay, is 0.805. This is a positive one. So here the school climate is a positively the positively effect on academic achievements. Then now questions for you. This question, you want to see which type of fertilizer helps plants grow fastest. So you add a different brand of fertilizer to each plant and see how tall they grow, right? So use chat box. What is the independent variables? What is the independent variables? Use chat box. So based upon this question, I am asking you two things. One is independent variable and dependent variables. So now you tell me which one is the independent variables. Which one is independent variables? Use chat box. Use chat box. Yes. So here, based upon this question, the type of fertilizer, that is a independent variable, right? Type of fertilizer is independent variables, right? Maybe you can use the chemicals, any chemicals or organic fertilizers, any type of fertilizers you can use, right? So type of fertilizer is a independent variables under the plants grow. Okay, so the plants grow is a dependent variables, right? So independent variables. So there is a the type of fertilizer, that is a independent variables. Then dependent variables. So the plant height, plant height. Next question for you. You are interested in how rising sea temperatures impact algae life. So you design an experiment that measures the number of algae in a sample of water taken from a specific ocean site under varying temperatures. Right. So now what is the independent variable? What is the dependent variables? Dear participant, please use chat box. Yes. So the temperature, okay, ocean temperature is a independent variables, right? The number of algae in the sample is a dependent variables, right? See, now come to the multiple regression analysis, right? So the multiple regression analysis, it is the predict the value of a variable based on the value of two or more other variables, two or more variables. Okay, so only one variable, one independent, one dependent variable means no problem. We can use no simple regression or linear regression we can use, but okay, two or more other variables means right, that time you should use the multiple regression. So here I given one example. If you read the example, you can easily understood, right, what do you mean multiple regression analysis, how to use the multiple regression analysis, right? See the yield of the rice per acre. Okay, yield of rice, there is a dependent variables. Yield of rice per acre, there is a dependent variables, but it depends on means quality of seed. This is a one independent variable. No? Then second independent variable, fertilizer of soil. Then third independent variable, fertilizer used. Then fourth independent variable, temperature. Fifth independent variable, rainfall. So now all these five, okay, see the the independent variables, like quality of seed, fertilizer of soil, fertilizer used, then temperature, rainfall. These all five variables are called independent variables. So all these five independent variables impact on yield of rice per acre. Okay, so now what we'll do, when we are using this, the five independent variables, one dependent variable, right? Now what we can, what result will get, it means right, joint effect of all these variables on rice yield. One can use these techniques. Okay, see now five independent variables. No, quality of seed, fertilizer of soil, fertilizer used, temperature, rainfall. This among the five independent variables, which variable impact, more impact on the yield of rice per acre. Okay, so which one is a positive impact and which one is a negative impact, right? Among the positive impact, which one is the highest, the mostly positive impact, and the negative impact, which one is a very highly negatively impact on yield of rice per acre, right? So here yield of rice per acre is a dependent variable, right? Quality of seed, quality fertilizer of soil, fertilizer used, temperature, rainfall. These five variables are independent variables, right? Next, questions for you. Questions for you. Multiple regression analysis is used when? Please use chat box A, B, C, D. Please use give the give the answer. You type A, B, C, D. Anyone. Okay. So multiple regression analysis used when? Option A, there is not enough data to carry out simple linear regression analysis. Option B, the dependent variable depends on more than one independent variable. Option C, one or more of the assumptions of simple linear regression are not correct. Option D, the relationship between the dependent variable and the independent variables cannot be described by a linear function. Please use chat box, dear participants. Which is the right answer? A, B, C, D. Use any one option. The question is multiple regression is used when? Okay. So option B. Option B is the right answer. The dependent variable depends on more than one independent variable. Then next question. Next question. Next question. The coefficient of determination. Coefficient of determination. Right? Option A. The coefficient of determination is maximized by ordinary least squares. Option B has a value between 0 and 1. Option C will generally increase. Yes. Option D is Dr. Raghu. Yes. Option D is the right answer. Thank you, sir. Raghu sir, Dr. Raghu sir, thank you. Okay, the answer is the coefficient of determination, all the above. Okay, the coefficient of determination is maximized by ordinary least squares. The coefficient of determination has a value between 0 and 1. Then the coefficient of determination will generally increase if additional independent variables are added to a regression analysis. Right? Thank you. Yes, Raghu sir. Next, multicollinearity. Okay, see nowadays, the researchers they are checking the multicollinearity. So multicollinearity means right. See the phenomenon is in which one independent variable is highly correlated with one or more of other independent variables, not dependent variables. Yes, Anjali madam, right, thank you. D answer is D. Thank you. Yes. See the multicollinearity nowadays we are checking the in the relationship between the independent variables also, right? So which one independent variable is highly correlated with one or more of the other independent variables, right? In a multiple regression equation. Okay. So previous slide I shown this one. Yield of rice per acre is a dependent variable, but the independent variables, right? Seed, then fertilizer, type of fertilizer, right? So these are all independent variables, right? So which one is very highly correlated with the highly correlate means what? Which means very highly this one relationship with the other independent variables, right? So now I'll tell you. See, now you see the screen. Now see the screen, right? So we can see that we have a high correlation between variables x5, x6, right? So here x1, x2, x3, x4, x5, x6 are independent variables. Y, okay, see the last y is there. See here one y is there. Okay, so y is that is a dependent variables, right? But x means independent variables, right? So that's why the linear regression we saw that y equal to alpha plus beta x, right? So y is the dependent variables x1, x2, x3, x4, x5, x6 are independent variables. So you see the independent variables, different relationship given between the dependent variables and independent variables. But here x5 x6, if you see the x6, okay, 0.8, then x5 0.8. So compare with other variables. See, compare with other the value variables, right? So the x5 x6 is the highest. Okay, the most more relationship is there. Okay, so that's why that the hard rule, what threshold is considered too much correlation but it's a common practice that anything at or above 0.5 should be explored. Okay, so which one is the 0.5? That and all should be more correlation, high correlation between the variables. So here only this this only is highest one. Okay, but others variables are not less than 0.5, right? So see the first paragraph, last line. See the common practice that anything at or above 0.5 should be explored. See, then you see the left side, that the boxes. Okay, x1 x2 x3 x4 x5, then x6, right? Independent variables, then dependent variable y, right? So now you check the multiple collinearity among the this one independent variables. Okay, in the independent variables, any variable, any variable, the value is 0.5 and above, means that and all high correlation between the variables, high correlation between the variables. So based upon this image, right, only two variables, x5 x6, only having the more than 0.5. Okay, so there is a 0.8 x5 and 0.8 in the x6. So these two values only higher than 0.5. So this x5 x6 are high correlation. There is a high relationship in the independent variables, right? Next question for you. Yes. Multiple as a multicollinearity refers to a situation in which, yes, so option A, successive terms terms derived from the application of regression analysis to time series data are correlated, right? Please read the yes, read the questions. Yes, Raghu sir given answer, option B. Yes. Any other options? Any other participants? See, multicollinearity refers to a situation in which, okay, yes, you see the answer. Okay, Raghu sir given the B option. Yes, B is the right answer. There is a high degree of correlation between the independent variables included in a multiple regression model. Thank you, sir, Raghu sir. Right. So before that, I'm going to share this one. Yes. This is SPSS. I will explain how to calculate, do, no, do the regression analysis by using the by you by using the the statistical package for social science, SPSS, right? So before going to this SPSS, show the the this one questionnaire. Yes. So in this, SPSS master table, right? So the researcher conducted a study on impact of human resource development practices on organizational development. Okay. So here, in the independent variables, the researcher used the human resource development practices. Sorry, human resource planning. This one. Human resource planning, staffing practices, incentive practices, performance appraisal, training program, teamwork, employee participation, right? So I will explain to you how to conduct the regression analysis, right? So in the SPSS, right, go to analyze, click analyze. Just to explain to you. Then after the experiment, I will explain the interpretation also, how to write the interpretations, right? So in the analyze, right, regression is there. Okay, regression. Here linear regression you select. Linear regression, I will select. So here dependent variables. Sorry, dependent variables, right, means I'm taking no organization developments. Organizational development is a dependent variables, but independent variables, I'm taking human resource planning, staffing practices, incentives, performance appraisal, training program, teamwork, employee participation. Okay, so now how many independent variables? 1, 2, 3, 4, 5, 6, 7. 7 independent variables. So 7 independent variables. You see, only one dependent variable, that is called organization development, right? See, human resource planning. Say human resource planning, one independent variable. Then staffing practices, second one. The incentive practices, third one. Fourth one is performance appraisal. Fifth one is training program. Sixth one is teamwork. Seventh one is employee participation. Right? So now it is a more than 2 independent variables, right, but only one dependent variable. So it is called multiple regression analysis. Then you click OK. You will get the answer for the regression analysis, right? So in the regression analysis, see the model summary. The model summary, the R, okay, R 0.503 is R. R square is 0.253, right? So you see below this table, the predictors. Predictors means the independent variables. They're constant variable. That is called employee participation, training program, staffing practices, human resource planning, incentive practices, teamwork, performance appraisal. All 7 variables called predicted variables called independent variables, right? Next one, I will after that I will explain the interpretation, right? So in this ANOVA, you see the SIG means there is a p value. The p value means 0.000, right? It is less than 0.05. So null hypothesis, is rejected. Then alternate hypothesis accepted because this p value is less than 0.05, right? Then you see the coefficient. So here also, below the ANOVA table also, they clearly mentioned that dependent variable, organizational development, then predictors, right? The constant variable, independent variables, all 7 variables are given, right? So now come to this point, last box, the coefficients. Say the model one. Okay, human resource planning, staffing practices, incentives practices, performance appraisal, training program, teamwork, employee participation. You see here which one is less than say which one is a minus negative value. Okay, see the minus 0.151. This is a human resource planning, and another one is incentive practices minus 0.635, and another one is on teamwork minus 0.147. These three variables are negatively impact on independent variables, right? Remaining variables are the positive influencing. Okay, so now I'll explain how to write the interpretation. Right. So here the heading, right? Impact of human resource development practices on organizational development. Impact of human resource development practices on organizational development. Okay, so here now human resource development practices are independent variables. Okay, so here now human resource development practices, there are 7 variables, right? So human resource development practices are independent variables. Then the organizational development is a dependent variables. Okay, so here what is our study? How this independent variables, human resource development practices impact on organizational development. Then see the hypothesis, the null hypothesis, right? Human resource development practices are not having impact on organizational development. Okay, this is a null hypothesis. Then what is the alternate hypothesis? Human resource development practices, human resource development variables are having impact on organizational development, right? So now see this one, this table I have taken from the SPSS output, right? So R value, R square value, adjust R square, this and all that. But this value is very important. So R square only very important, right? So because in the first slide I explained that okay, the variation, okay, see how much variations in the dependent variables, right? So the R square nothing but, right, the coefficient of determination. R square means what? A coefficient of determination. That is the value is called, the value is here 0.253. Okay, so 0.253 into 100. Okay, so what is the value? 25.3 percentages. 25.3 percentages, right? The variation. This is the no, this is one. Okay, variation in the organization development. Organization development means what? So 25. Now this the independent variable is having a 25.3 percentage of variance in the dependent variable, right? So next you see next table, another table. Okay, so another table here the p value, this is called p value, significance value, that is called right, the p value 0.000. Okay, so the p value is less than 0.05. So automatically what we'll do, we should be reject the null hypothesis, accept the alternative hypothesis. Okay, so what is our null hypothesis, right? So the human resource development practices are not having impact on organization development. Okay, so now we should be reject the null hypothesis and accept the alternate hypothesis. What is alternate hypothesis? The human resource development practices are having impact on organizational development because this p value is less than 0.05. Okay, so now you see no, this one, this is the p value 0, this one alpha. Okay, alpha means the level of significance, right? 0.05. Okay, then see human resource development practices, right? Employee participation, yeah, training program, staffing practices, human resource planning, then incentives practices, teamwork, then performance appraisal. These are the independent variables. Are, see here, this is important, are having impact on organization development. Because why? The p value is less than 0.05. So we shall reject the null hypothesis and accept the alternate hypothesis, right? So because no, the hypothesis null hypothesis accept or reject based upon the p value. Okay, suppose p value is less than 0.05 means null hypothesis rejected. Okay, so then alternate hypothesis accepted, right? See now this one, coefficients coefficients of for impact of human resource development practices on organization development. That's OD, right? See now, see human resource planning. Okay, what is the the beta value? Okay, b value here minus 0.151. Minus means what? Negative, right? Negative. Okay, so the human resource planning, the negative impact on organizational development. This one point. Okay, then you see staffing practices 0.590 is a positive impact because it's a plus, okay, not minus. Then incentive practices minus 0.635. Okay, there is a minus. Minus means what? A negative impact. Okay, so in incentive practices are negatively impact on organization's developments. Then performance appraisal. It is one of the independent variable. See, 1.038 is a positive impact on organizational development. Then training program 0.455 is a positive impact on organization development. Then teamwork. Teamwork is minus 0.147. It's a negative. Minus means negative. Then employee participation. Employee participation 0.024. Okay. So there is a positive impact. So now you should be classify, right? Classify the independent variables, right? Which are the positive impact on or organization development, and which are the which independent variables are negative impact on dependent variables. Okay, I can tell you here in this study, independent variables are called organization, sorry, human resource development practices. Dependent variables, organizational developments. Okay, so dependent variables there is no changes, but independent variables there are 7 independent variables. Out of 7 independent variables, how many variables are positively impact on organization development? How many variables are negatively impact? Okay, so after that we should be identify which factors positively highly impact. Okay, see now I'll tell you. See this paragraph. See, organization staffing practices 0.590, performance appraisal 1.038, training program 0.455, and employee participation 0.024, right, are influencing positively the organization development. Okay, so because all the positive values. Then you see next, organization development planning. Say human resource planning minus 0.151, teamwork minus 0.147 are negatively influencing. Okay, so from this regression analysis, right, we can say that whether there is independent variables are having impact on dependent variables or not. Okay, so if it is there means, if it is impact means, right, which are the the positive impact, having a positive impact, and which are the negative impact. Okay, the positive impact also you see here: staffing practices, performance appraisal, training program, employee participation. Okay, there are 1, 2, 3, 4 independent variables are positively influencing the organization development. But among the four, out of four, right, the performance appraisal. See, the performance appraisal, the value is 1.038. So compare with the status, the staffing practices, training program, and employee participation. See, the performance appraisal is highly positively influencing the organizational development. Right? So this is the conclusion. So how to write, right?
Thank you, sir. Participants, if you have any question, you can post it in the chat box. Good day, one and all present here. I, on behalf of the Department of Commerce, extend a very hearty vote of thanks to the resource person, Dr. M. Gurusamy sir, for gracefully accepting our invitation to share his wisdom on regression analysis. Thank you for making the session an interactive platform and dealing with the queries of the participants, sir. Thank you so much. We would also like to thank the management, Dean, principal, and head of the departments for their support in the organization of this FDP program. We also thank all the participants for taking part in this program. Once again, thank you all. Thank you, sir.
Thank you, madam, for giving me opportunity. Harini, madam, and Rubavati, madam, and other participants. Right. Thank you very much for attending the session. Thank you very much, madam. Like to thank now
Thank you, sir.
your college management, dean, principal, all. Thank you very much for giving me wonderful opportunity to meet the all the participants through the platform. Thank you. Thank you.
Thank you, sir.